So what we have learned so far, the confidence interval for population. The steps that we learned to follow for this part is, first of all, we need to find the point estimate. The point estimate for the population proportion is denoted by p hat, which is equal to x divided by n, the number of successes that we have divided by the sample size. The successes that we have divided by the sample size. Then we need to identify what is the confidence level. The confidence level, some famous ones are 90%, 95%, and 99%. Again, remember that if the confidence level is not given to us, it means that we can use 95%. So in the case that the confidence level, if confidence level is not given, we use 95%. After finding the confidence level, we are interested in finding the critical value, which is Z sub C. After finding critical value, then we are interested in finding what is the margin of error. What is our error? So when we're dealing with confidence interval for population proportion, this is our goal. The margin of error is ZC, the critical value, times square root of p hat 1 minus p hat divided by n. After finding the margin of error, then we can construct our confidence interval. The confidence interval is equal to p hat minus the margin of error and p hat plus the margin of error. And eventually, in the final step, we say that we are confidence level, confident, so blank %, confident that our population proportion is bounded between p hat minus e and p hat plus e. These are the steps that we took when we were trying to find the confidence interval for population proportion. Let us go over some more examples, then we're going to learn about the sample size. So in this example, the question says, you have a survey. In a survey of 1,000 US teenagers, teens, 372 said they own smartphones. So question says, construct a confidence interval for population proportion. Construct a confidence interval for population proportion. What is population proportion? It is denoted by P. This is my population proportion. My goal is to construct the confidence interval for population proportion. We go step by step and try to form the confidence interval for population proportion, what is our goal? Our goal is to come up with the best population proportion, but since we do not have information about population, we're going to form a confidence interval, including possible population proportion. What is our first step? Our first step is to construct the population, the sample proportion, which is representing the population proportion as an unbiased point estimate. So let's take a look at step 1. X divided by N. What is X? X is the number of success and N is the sample size. So X is 372 and N is 1,000. So let us just plug those in and find P hat, or the point estimate, which is sample proportion. 372 divided by 1,000. So our proportion is 0.372. We found the sample proportion. Now we need to identify the confidence level. Do we have any information about confidence level here? Is it given to us? Well, I don't see any confidence level. It means that I'm going to work with 95%. The confidence interval is 95%. So we're done with the point estimate. We're done with the confidence level. Now we need to find the critical value. Remember that for critical value, you can use your calculator. Well, in finding the critical value for 95%, what we can do, we can graph the normal distribution. This is our normal distribution. 95% of the area is going to be here, 95%. So what's left? 5% is left. 5% to the right, 5% to the left is 0.025. When you're using your calculator to find the critical value, we're going to go to second, vars, and then we're going to find the inverse norm. In inverse norm, we're going to enter area to be 0.025. The mean is 0 and the standard deviation is 1. So let us take a look at this. This is my calculator. Let me turn on the calculator. Well, second vars, inverse norm, the area is 0.025. The mean is 0 and the standard deviation is just 1. So let us enter, and as you can see on the left-hand side, we have negative 1.96. This is my Z, not critical value. This is negative 1.96. My critical value is the absolute value of this number. So critical value is equal to positive 1.96. ZC is 1.96. So we found step 3, which is our critical value. Let us move on to next step to find the margin of error. Margin of error for population proportion has a formula. This formula is ZC, critical value, 1.96, multiplied by, well, P hat, is this, P hat, what is P hat? We already calculated P hat, which is 0.372 times 1 minus 0.372 divided by n. Remember that our n is our sample size, which is 1,000. Let us do the calculation. What is the margin of error? So we're going to use our calculator to find the margin of error. We have 1.96 times, now we are dealing with the radical, so second x squared, and I'm going to use a bunch of parentheses because I want everything to stay inside my radical. We have 0.372 times parentheses 1 minus 0.372. Let me close up the parenthesis and divide by 1,000. As you can see, all quantities stay inside the radical. Let me enter. Well, the margin of error is almost 3%. So my margin of error is 3%. We just found this number. Almost 3%. I found P hat, the point estimate for my population proportion. Then, since in this question there is no mention of confidence level, I'm going to go with 95%. I use my calculator to find the critical value, which is 1.96, 1.96. And then I use the margin of error formula to calculate the margin of error, which is 0.03. And finally, I go to step 5 to calculate the confidence interval, which says, hey, we have P hat 0.372 minus the margin of error 0.03, comma, P hat 0.372 plus the margin of error. So if we just use approximation, it seems like we have 0.342 and here we have 0.402. So what's the meaning of that? This is the confidence interval for population proportion. Confidence interval for population proportion. But what is the interpretation here? What is the conclusion? We say that, hey, in the final step, step 6, we are 95%. We are 95% confident that the population proportion of teens who owns smartphones, of US teens who owns smartphones is between 34.2% to 40.2%. 34.2% to 40.2%. This is our conclusion. Following these steps help us to find the population proportion and an estimate that we are 95% confident about this process. Now, let us use our calculator to make sure our calculations are correct. to use your calculator, you go to Stat, you go to Tests, and then since it's about population proportion, you need to find one proportion Z interval. One proportion Z interval in your calculator helps you to find the confidence interval in much more accurate way. What is X? X is 372. What is N? N is the sample size, 1,000. Confidence level, we already selected 95%, and let us do the calculation. As you can see, the confidence interval given in the calculator is 34.2% and 40.2%. So we did a very good job, very accurate confidence interval using the data given in this question. Now, suppose the question says, construct a confidence interval for population proportion with confidence level equals to 90%. So now the question says, hey, your confidence level is 90%. Well, what should I do? I should go over each of these steps to construct the confidence interval. So what is the very first step? The very first step says, hey, construct your point estimate p hat, which is the number of successes, divided by n. What is X? The number of US teams who own the number of successes that we have is 372. 372 out of how many members, how many people participated in this survey? 1,000 people. So the point estimate is 0.372. So we're done with the very first step. What is the second step? Confidence level. Confidence level, in the question, it says, hey, I want you to form 90% confidence level. Okay, we know what the confidence level is, 90%. Now, what is the critical value associated to 90% confidence level? Very well. So as we know, the confidence level is 90%. To find the critical value, we can use our calculator. Well, to use our calculator, we graph the normal distribution. This is my normal distribution, and 90% of the data are located here. 90% of the area. So 10% is left. It means that 5% is to the left and 5% is to the right, 0.05. And then we can use our calculator, go to second, vars, inverse norm. So second, let me write it here. Second, vars, inverse norm. Okay. Second vars, inverse norm, and then enter the area. The area is 5%. 0.05. The mean is 0, standard deviation is 1 because we are working with z values, z scores. So when we enter that, the z value is negative 1.64. Negative 1.64. So the ZC, the critical value, which is the absolute value of negative 1.64, is going to be positive 1.64. Very good. Now let us move on to step 4 to find the margin of error. The margin of error has a formula. It is ZC, which is 1.64 from step 3 times the square root of p hat 1 minus p hat. We already calculated p hat, which is 0.372 times parentheses 1 minus 0.372 divided by n. N is the sample size, 1,000. So let's see what is the approximation that we have. So I'm going to write 1.64 times square root of, well, remember to use parentheses, 0.372 times, well, 1 minus 0.372, close the parenthesis, and divide by 1,000, and close up the parenthesis. Approximately, we get 0.3%, almost 0.3%. So we found the margin of error. What is the confidence interval? The confidence interval is p hat, which is 0.372 minus 0.03 and 0.372 plus 0.03. Our confidence interval approximately is, well, if we do the subtraction, we get 0.342, comma, 0.42. Again, we are 90% confident that, this is the interpretation, the last step, we are 90% confident that the population proportion of US teens that they own smartphones is between 37.2%, sorry, 34.2% and 40.2%. Well, we talked about the confidence interval. Now I expect you to ask, how do I find the sample size, minimum sample size needed for that estimation? Can I take any sample? Let us erase these and write down information here. What is the minimum sample size? Minimum sample size. Given in confidence level or C confidence level, suppose the confidence level is given to us. Let the margin of error be given as E. Then the minimum sample size N needed to estimate the population proportion follows the formula. N is equal to P hat 1 minus P hat times, you find the critical value, divide by the margin of error raised to the second power. The information that we need are p hat, critical value, margin of error, to be able to find the minimum sample size n. If we have these information, then we can find what is the number of people or the data needed in our sample. So how many outcomes must be there so our confidence interval give us the accurate information that we need to interpret the results. This is very important. Can I take any sample size? Is it possible just to take randomly 10 people, take randomly 20 people? Let's go over one example together. This example says, you are running a political campaign. A political campaign, and you wish to estimate with 90% confidence level the population proportion of registered voters who will vote for your candidate. Very good. So your estimate must be accurate. Within 3% of the population proportion. Find n, the minimum sample size, when no preliminary estimate is available. Very good. So what do we have here? What information are given to us and how we can use this formula? Take a look at the question, read it carefully. You are running a political campaign. You wish to estimate with 90% confidence level. Well, we have the confidence level, right? The confidence level is given to us as 90%. So we can easily calculate the critical value. The critical value for 90% is 1.64. Okay, so far so good. I need p hat, I need 1 minus p hat, I need zc, I need e. I already found zc. So my n so far is, I don't know what p hat is. I don't know 1 minus p hat. I only know zc, which is 1.64. So let us enter that. 1.64. And then I don't know what goes on my denominator. What is the margin of error? We need to find each one of these step by step, one by one. Okay, let us move on. The P population proportion of registered voters who will vote for your candidate. Your estimate must be accurate within 3% What is this 3%? This 3% says real information related to population proportion within 3%. It means that my error is 3%. My error is 3%, 0.03. So this goes on the denominator. One by one, we try to find all of these missing information and calculate the minimum sample size. Okay. It says find n when no preliminary estimate is available. So what do we do in these cases when no preliminary information are given about sample or point estimate? In this case, you always assume that the population unbiased estimate or p hat is 50%. So when no preliminary estimate for your point estimate is given, this is always fixed. Half of the sample is success. So p hat is 50%. This is the rule that we have. So let us plug that in, 50%, and 1 minus 50%, which is also 50%. So let us use our calculator and find the minimum sample size. Let's turn on our calculator. We have 50% times 50% times, I need parentheses here. So here I have x squared, let me erase this. So 50% times 50% and times, let me open a parenthesis here, 1.64 divided by 0.03, close the parenthesis and raise to the second. Very good. Well, what is this? This is 747. 747.11. So it means that the minimum sample size needed for me is almost 747 people in that sample. So I need collect data from a sample with size 747.